Welcome back to another class on critical thickness of insulation. In this class, we'll work out another example on critical thickness of insulation for a cylinder. So we'll work out an example. An electrical wire of 10 meter length and 1 mm diameter dissipates 200 watts in air at 25 degrees centigrade. The convection heat transfer coefficient between the wire surface and air is 15 watts per meter square Kelvin. Calculate the critical radius of an insulation K is equal to 0.25 watts per meter Kelvin, and also determine the temperature of the wire before insulation and after insulation for the critical thickness of insulation. So an electrical wire 10 meter length and 1 mm diameter, it dissipates 200 watts with the surrounding air temperature 25 degrees centigrade. The convection heat transfer coefficient is given 15 watts per meter square Kelvin. So heat dissipation is given 200 watts. That is from the bare wire. Now we are providing critical thickness of insulation with an insulation material having thermal conductivity 0.25 watts per meter Kelvin. Now we have to find out the cable surface temperature, determine the temperature of the wire before insulation and after insulated for critical thickness of insulation. Now the data given is ambient temperature 25 degrees centigrade, T1 is not known, okay. Thermal conductivity of the insulation material is given. Heat transfer coefficient, outside heat transfer coefficient is given. So diameter is 1 mm, radius is 1 by 2, 0.5 mm or 0.005 meter. Heat transfer from the bare wire you can calculate, but heat transfer is given. So only thing is that cable surface temperature is not given. So it has to dissipate 200 watts. The bare wire has to dissipate 200 watts. So bare wire heat dissipation from bare wire is T1 minus Ti divided by 1 by H naught. So Q is known, 200. Temperature of surface is not known, but ambient you know, and R1, the radius is known, 0.005, and the length is 10 meter, H naught is known. So you get the cable surface temperature as 449.413 degrees centigrade. So this is the cable surface temperature for a heat dissipation of 200 watts. This is a very high temperature. This is without insulation. If the wire is dissipating 200 watts, this would have been the temperature of the cable surface. Now, such a high temperature cannot be permitted on a cable. So we are going for insulation. We want to dissipate heat at a faster rate and reduce the cable surface temperature. So we are providing critical radius of insulation. So with that insulation material given, the critical radius is K by H naught. K is 0.25 watts per meter degree centigrade. So H naught is 15 watts per meter square degree centigrade. So you are getting RCS 0.01667 meter. That means 16.67 millimeter. So that is the outer radius of the insulation for maximum heat dissipation. Now heat transfer from an insulated wire you can calculate. We have the formula T1 minus Ti divided by 1 by 2 pi KL log RC by R1 plus 1 by H naught. Now we got the critical radius. You can substitute critical radius. R1 is already known. Thermal conductivity length is known 10 meter. So 1 by H naught. Area is 2 pi RCL. Area is 2 pi RCL H naught. So this is a formula to find out the heat transfer from the insulated wire. Let us substitute for this. So T1 minus 25 divided by 1 by 2. T1 is still unknown. From insulated wire, the cable surface temperature will decrease. So T1 is not known. So T1 minus 25 divided by 2 pi. K is 0.25. L is 10 meter. This is the critical radius which we have calculated. Radius of the cable, and here again critical radius, length, and heat transfer coefficient. After substituting all that for 200 watts heat dissipation. Now once you solve, you get T1 as 82.379 degrees centigrade. Now the cable surface temperature has decreased by providing the critical radius of insulation or critical thickness of insulation. The cable surface temperature we could reduce to 82.379 degrees centigrade. So insulation reduces the surface temperature of the cable by increasing the rate at which the heat is flowing out. So at a reduced temperature, the cable, if it is dissipating 200 watts for this constant heat dissipation, insulated cable can transmit the same amount of heat with a lesser temperature difference because resistance is less for heat flow. With a lower temperature difference, the insulated cable can transmit the same 200 watts of heat. Thanks for watching. Keep watching this channel for more such videos.